Hello everybody, I am Krishna Rao Patro. Today we will discuss about one more important concept of the collection class, means collection framework, that is linked list. How linked list you can use in the collection framework. Those things we will discuss. I hope in the previous session we have seen how to use array list and how to use vector and all. Now we will see one more class that is called linked list. So linked list is also one of the class in the collection framework. The linked list is a part of collection framework present in a java.util package. So in my util package, there are many classes comes under collection framework. So one of the important class is linked list. This linked list class, which also behaves like our normal linked list in our data structure concepts. How we have used the linked list in data structure, same thing you can use in an easy way with the help of those built-in methods. This class is implementation of linked list data structure. The linear data structure, that is single linked list, double linked list, everything is there. No, in a similar way, same type of things you can implement with the help of this linked list class. A linked list in Java is a dynamic data structure whose size increases as you add and decreases as you remove. So whenever you are adding the data, then the linked list size will increase. Whenever we remove the data, the linked list size will decrease. So it is a more flexible data structure. It is a dynamic array type. So in linked list, you can add an item, you can remove an item in the easiest way. So that is the advantage of the linked list over the other classes. The elements in the linked list are stored in a container. The elements in the linked list are stored in a container. The container can store any number of items. There is no restriction. You can observe here a linked list is internally implementing the double linked list data structures. Linked list class internally uses double linked list node. So it is a node. This node having what? Data path, left link, right link. The left link will be holding address of the previous node. Right link will be holding address of next node. Every node will have address. For example, this node address is 200. This node address is 200. This is 300. So now this right part will be holding the address of next node. That is how much 200 will be here. Similarly, here there is no previous node. When there is no previous node, it will be null. It will be null. Similarly, this node also what? It is a double linked list node. We are having the two parts, left link and right link. This will be holding the previous node address 100. This will be holding the address of next node 300. So like this, it is maintaining. So internally, it organizes the data by interconnecting the nodes. So the last node, now in this example, there are three nodes, which is pointing to null, and this will be holding the previous address. That's how much? 200. So that means internally it maintains a double linked list. So double linked list data structure is more convenient than single linked list. So your linked list classes uses the double linked list data structure. So this is a simple diagram of linked list class. Java linked list class uses a double linked list to store elements. So whatever the classes are available under the util package, those classes, means the linked list class, internally uses the double linked list data structures. Why? Because with the help of the double linked list data structure, it is more convenient to traverse left to right as well as right to left. Plus, you can add one item, you can remove an item easily. So modification is dead easy. That's why double linked list is used in linked list class. It provides the linked list data structure. It inherits the abstract class. And implements the list and DQ interface. So if you observe the diagram, first one is iterable and next one is collection. From iterable, whatever the methods are there, everything is available in the collection because collection is the derived interface from the iterable. This collection interface is implemented in the list as well as queue. Whatever the methods are there in the collection, everything is implemented here. And then abstract method. So the linked list comes here. The linked list implements the abstract sequence list as well as the DQ. So with the help of these methods, you can implement all the operations of linked list. You can add a node, you can remove a node, You can add a node in the middle. You can add a node at the end. Similarly, you can remove a node at the beginning. You can remove a node at the end. So all types of operation you can do easily. So this is the hierarchy of the classes for the linked list. How linked list is organized internally, you can see now in this diagram. There are some important points you should remember under the Java linked list. The first one, Java linked list class can contain duplicate elements. That means in this linked list, you can throw duplicate item also. There is no restriction. Just it will say nodes are there or not. In that node, what value is there? It will not bother. Same value you can repeat in multiple node also. Because when I say node, it is nothing but there is a data part and there is a link part. The link part holds the address of the next node. So this data part may be duplicate. I can have multiple node. In the multiple node, same data may be there also. Java linked list class maintains insertion order. The order you insert, same order it will be maintaining. So the insertion order plays major role. Whichever you are entering first, that will be the first position. If you are entering next, second position. Whenever you keep on adding, that will follow the order. That means follow one indexing. It follows some index. Java linked list class also non-synchronized. That means it is not thread safe. It is non-synchronized. In Java linked list class, manipulation is fast because no shifting required. Manipulation is easy. Whenever you want to swap two nodes, you can interchange with a simple logic. So it takes less time. It is more convenient, more flexible for doing any manipulation on the nodes. Java linked list class can be used as a list, stack or queue. The linked list you can use as a stack as well as you can use as a queue also. It is more flexible. It is also resizable. It can grow and shrink. So memory point of view is the best data structure. Similarly, whenever you want to swap two data also, easily you can swap. You can transfer one node to another node also by simply swapping the address. So it is also more convenient data structure. So these are the important point you should know. Now there is a small example. Anyway, I will show you what are the methods are there. Before that, let us see a small program on the linked list. Whenever you are using the linked list program, you have to import first java.util.start. This package holds the linked list. And this is my class name, linked list 1. Public static void main string. Then here in the node, you can store string, you can store integer, you can store float, you can store any object also. So here linked list is the built-in class. Within the angle bracket string, that means it is also a generic class followed by AL. Followed by AL. This is the name of the linked list object, the linked list string. So that means my linked list object is ready. Here I can add particular item. For example, first item is Ravi. First item is Ravi. First item. Next Vijay. Vijay. That means internally it creates what? One node. Vijay. For every node there is address. For example, this address is 100. This is 200. Now this 200 will be there automatically here when you are adding. It follows order, insertion order. It follows the insertion order. Next, Ravi. Again, Ravi will come here. Assume 300. Even though first name is Ravi, second name also you can insert Ravi. So 300. Like this it is maintaining. Then Ajay. Ajay. So you can store same item multiple times again in a order. Now this program creates how many nodes? 1, 2, 3, 4. 4 nodes are created. And every time the last node will be holding null value. That means it says no items are there. Now using this iterator, you can iterate, you can traverse. In the linked list, there is a process called traversing. You can traverse from left to right. Now using iterator, if you traverse, first data is Ravi. Next Vijay. Next again Ravi. Next again Ajay. These 4 information will come from this linked list. This is from first node. This is from second node. This is from third node. This is my fourth node. It follows the insertion order. This is a simple program to create a single linked list with the 4 nodes. Single linked list with 4 nodes. With the 4 nodes. I hope it is clear. It is a very simple one. So which class you use? Linked list class. Linked list class belongs to which package? Under util package. So now if you run, anyway, I'll show you one program also through my notepad, but try to know this thing. Now, go to another program. How to combine 2 linked lists. Means so, assume linked list LST. LST is my linked list having B, java2s.com and E and F. This is my some information. B is in first node. From B, 1, assume here I'll write instead of this lengthy name, I'll put J. J will come. After J, then again E will come. After E, then F will come. Sorry, this is B, this is J, and this is what? Add last. Add last and add both are same only. Because first B added, then J added, then add last, E added. After that, add F. So automatically it goes to last only. Now, my linked list having how many nodes? 4 nodes. First B, then J, then E, then F. So 4 nodes are added. Now, I am creating one more list. This is my LST. This is my LST object. This LST object referring to this area. Now, I am creating a new list with LST as item. That means you can create one more linked list with the help of existing linked list. So, it will create one more list. New list with the same thing. What? First one is B, next one is J, next one is E, next one is F. This way you can create. So that means existing linked list you can use to create a new list also. Now you can print the list. Now I'll show you the program on this. Let us go to our notepad, how you can use it. Go to notepad, Control N. What is my goal? To use the linked list program. Now before going to linked list program, you should know what are the methods are there and what are the constructors are there. Once you know those things, then you can do program. So before that, I will show you what methods are there. So how to go to that place? I will go to my command prompt. Okay, here I will write is because I want to go to command prompt. Class linked list or link demo is my name of the class. The name of the class is link demo. Control C, Control S, Control V dot Java. This is my program. Okay, go there. Go to command prompt. Yes. Now, what is my goal? To know about the methods of linked list. So, to know that one, there is a tool called Java P. So, please remember there is a tool called Java P followed by java.util.linked list. So, that means you should know where this class is available. Once you know the location in which package is available, then you can know what are the methods are there. So, what is my target? To know the set of methods available in the linked list class. Yeah, so many methods are there. Now, those methods I will pass to a temporary file called x.txt. Now, I will open that file. Yeah. Now, if you observe there are 2 transient variables. First, last, size, and the linked list. You can create a linked list without parameter. You can create a linked list with one more linked list. Okay. You can create, so you can use get first, you can use get last, you can use remove first. So, you can fetch any data from the linked list. Get the first node means you can call get first. Get the last node, you can see get last node. Similarly, remove the first node, remove the last node, add first. You can add one node as a first node. You can add at the end. So there are various methods are there, and you can write size method. The size method will talk about how many nodes are there in a linked list. Similarly, add. You can remove a particular object from the linked list. You can add one more linked list to another one. So like this, the various methods are there. You can fetch, you can set. So you can remove a particular node by specifying the position. Now, if you demonstrate this one, what you have to do? Write a program to do. Let us store set of numbers. Plus public static void main string arguments array. This is my main method. Here, what is my goal? My goal is to use linked list class and to do the linked list operation. Import java.util.star. So here I am importing all the classes of util package. Of course, I know that linked list belongs to util package. And what I want to do? I want to do first create a linked list. Create a linked list. Initially list is empty. Next, add operation. Next, remove operation. Next, show operation. So these are my requirement: adding, removing, and showing. What are the nodes are there? I want to show it. Of course, if you want to say how many items are there, count nodes. Count node. Add node. Okay. Similarly, remove node. Similarly, show nodes. Now, in the linked list, what you can store? In the linked list, you can store any type of object. You can store any type of object. So let me create one first to a linked list with the integer data. Linked list is my name of the class. And if you want to store integer, then you should write integer here. INTEGR. Because it stores only the object form. So for every integer, if you want to store in object form, then you should write integer. Integer is a wrapper class for integer. Nums is the name of the linked list, or I can say num list, num underscore list. This is my name of the object. This I will initialize. Now tell me new linked list angle bracket integer then bracket. So it says that I am going to store pure numbers in my linked list. Now let me add. So now what I will do? Num list dot add. Add is a method. So assume I am adding 11. So automatically 11 will be added to the linked list. Again I'll say num list dot add. Assume 22. So 22 will be adding to the linked list. Again I'll say num list dot add 33. Now how many items are there? 3 items are added. Now let me, after adding, I want to traverse it. So how to traverse? You can traverse by different ways. First I will go in a normal way. Traverse the list. Traverse the list. Because here I am fetching one by one. What are the item I am storing? The integer type. So integer. Assume integer G. G is my item. Or I will say item. From where I should get? I should get from the num list. Num underscore list. Now After retrieving the data from the list, I will display it. System.out.println followed by the item. So whatever the item I am retrieving, that item I am printing. So now here I will write the list of items in the list. System.out.println list of items. Okay. Now let us run. Control Z, Control S, link demo, or as a linked demo, linked. Control S, Control C, Control S. I am changing that name to linked demo. Linked demo. Okay. Linked demo. Go to the folder. Compile it. Java C linked demo. Linked demo.java. Java should come. Linked demo. Control C. Control S. The name of the program should be linked demo.java. Save as linked demo.java. Extension should be .java. Otherwise you cannot run. Here, clear the screen. Java C linked demo.java. Yes, it has compiled. Now Java followed by linked demo. Yeah. Now I have added 3 items 11, 22 and 33. So these 3 items are. Now you may ask, because this is addition operation, it follows first 11, then 22, then 33. Now my linked list what holds 11, then 22, then 33. Now I want to add 7 at the beginning. I want to add 7 at the beginning. 7 at the beginning. So what to do? If you want to add 7 at the beginning, now I should add num list dot add first. There is a method called add first. So that means before 11 I want to add it. Add first 7. So automatically 7 will be added at the. Now go to the program. Compile it. Yes, compile. Run it. Yeah. Now I got 7 in the beginning. 7 at the beginning. Fine. Now I want to add. Now 7, 11, 22, 33 is there. Here I want to add after 33. I want to add 53. 53 at the end. So how to add at end? So now what I'll say? Num underscore list dot add last 53. 53 is added. So automatically the 53 will be added at the end. Now let us run. Compile it. Yes. Yeah. Now 53 has come to end. Did you observe? So this is the way you are adding at the beginning as well as you are adding at the end also. Now this is at 0th place. Once I traverse, what I am getting? I am getting this item. This is at 0th place. 0th place lo emundi. In 0th place, my data is 7. At 1st place, 11. At 2nd place, 22. At 4th place, 5th place. Total 5 items are there. Okay. This is 0, 1, 2, 3, 4. Now, I want to add 0, 1, 2. At 2nd place, I want to add 18. At 2nd place. Now what I will do? Now I want to add 18 at second place. Second place. That means 0th place 7 is there. 1st place 11 is there. Now at second place, that means after 11, I want to add 18. So what I will do for adding at second place, num list dot add at second place 18. Second place 18 should come. Control S. Compile it. Yeah, compiled successfully. Now run it. Java. Linked list. Linked demo. Yes. Yeah. Now 7, 14, 18. To the second place 18 has come. Now 22, 23. So this is the way you are able to insert at particular place. So this is the way you are. Now you have done all types of operation. What operation? Insertion operation. Insertion beginning, insertion end, and insertion in the middle, or insertion in the particular position. So what are the methods now you learned? This is insert. This method is insert. This is also insert. Where this is insert at beginning. Insert at beginning. Only add means what? Insert at end only. Insert at to end. Add last is what? This is also equivalent to normal add. Because the normal add method goes to end only. Fine. Whereas if I specify a position, this is the position, second position. Insert at specified position. At to position. So whatever the position you have specified, it will insert at that place. So remember the index starts from 0. So 0, 1, 2, 3. First node is 0, then 1, then 2. If at all you want to print the entire list at a time without writing this loop, you can print also. Control C. Before that, Control V. My list is what? Num list. You can write this also. Control S. You can traverse. Control S. Compile it. Yes. CLS. Java. Followed by nums list. Or linked demo. Sorry. Linked demo. Enter. Yeah. Now, if you observe here, now you got what? This is your one. So, you can display like array. So, internally, this linked list is using the double linked list data structure. But while displaying, it will display like a normal array. So, it is also one type of dynamic array. It is also one type of dynamic array. But its operations are fast. While interchanging, while deleting the middle nodes, that takes less time. It is more flexible data structure. Similarly, now you want to remove it. Till now you have seen how to insert the node. Now how to delete. Now I'll say. So currently how many nodes are there? 7, 11, 18, 22, 33. Now when you insert 18, after 18, what is coming? At second place. That means 0, 1, 2, 18 is there. 18. Yeah. So now my data is available in this form. Data is available in this form. Now let us remove it. How to remove? For removing the data, you can say that nums list dot remove. It will remove the item. After removing, let us check what items are. Now after remove. So now my last item is 53. First item is 7. Java C. Compile it. Now Java. Linked list demo. Yeah. So after removing my first node, how much? 7 gone. So when you say remove, always the first node will be removed. Always the first node will be removed. But if you want to remove the last one, so you can say remove last. Now let us remove last. Remove last. Now the last node, how much? 53 it has to remove. After remove last. Control S. Now compile it. Yeah. Now the 53 gone. Earlier 53 was there. Now the 53 is not there. So you can do any operation also. Fine. Now after removing 53, what I get? I got this value now. 18, 11, this 33. This is the final answer. So that means here I got this value. Now assume I want to remove 20 second. 20 second at available at, and 22 is available at second place. 0th place is 11. And remember, after every insertion or deletion, the indexing will be changing automatically. This is the main plus point of linked list. This will be now 0th item. This will be 1th item. This will be 2nd item. This will be 3rd item. Now, I want to remove 22 now. Currently, 22 is available at 2nd place. 0th place, 1st place, 2nd place. This 22 I want to remove. So, how to remove 22? For that, you can mention, after removing 2nd place, I want to display. Remove at position 2. After removing 42, remove the second data. After removing, what is that? Compile it. Now which data has gone? 11, 18, 22 has gone. 22 has gone it. Because this is the second position. So once you specify the position, it will go to that position and that item will be deleted. So this is the way you can remove the item. Is it clear? Now I want to know how many items are there in my list because I want to count it. For counting purpose, you can display count or there is a size method. Control V. Number of elements. Number of items. Number of items. Plus num list dot size. Control S. Yeah. Now the number of items are 3 because after deleting all the items, finally I got 3 items are there. So you can do this type of operation on the linked list. So linked list is also one of the important class of your collection framework. So try to use these methods. Similarly, the other methods also available. There are many methods are there. You can check. Assume I want to know what element available. Element at second place. What item is there at second place? So let me print element at. Control C. Item at second. Item at second. So now here get method is there. Get second item. What is the second item? Because after removing 2, this 22 gone. After removing 22, my list become how much? Once you remove, the list to become 22 gone. Now this become second. Which one? Because this become 11, means this is 0, this is 1, this is 2. So 33 is the answer. Control S. So let us compile it. Yeah, I got 33. 33 at the second position. So dynamically the index is changing. Once you Similarly, peak first, peak last. That means it will give the value. Peak means sets, get the value. It is also equivalent to the get method. But in the get method, you have to specify the position. Whereas in the peak method, you need not specify the position. From the name itself, it will guess. For example, I'll say peak last. I will apply this method. Once you apply this method, I should get the same item. Let me use the peak last. Control C. I want to apply peak last. The peak last gives you C. You can apply this peak last method here. Control S. Similarly, peak first. Peak FIRST, peak first. Now the peak first method gives you the first item of peak last is a method. Method means it should be method in this form. Peak first also method. Control S. Let us go to the program. Clear the screen. After clearing, Java C, link demo, .java, Java, link demo, enter. Yeah. Now the link peak last also 33. Item at 33, peak last 33, and peak first is 11. So 11 is the first item. So using peak method also, you can pick the particular item from the linked list. So this is the way you can apply all types of operations on linked list. Similarly, you can use for, you can use the element, you can use offer last, peak first, depending upon the requirement. You can use whenever you treat the linked list as a, what do you say, stack, you can use pop method. So when you say pop, the last element will be removed automatically. Let us use pop. How to use pop? Now let me pop it. Numlist.pop. Numlist.pop. Once you pop, the last element has to be removed. So now let me print my complete list. Let me print it. I want to print final item. The list of item after copy. After copy. List of item after copy. Here after copy. Control S. Compile it. Yes, compile successfully. Yeah. Now, if you observe here, after pop, I got 89. Earlier, the first item was 11. That 11 permanently removed. So, now, this item, 11, 18, 33 was there. So, the 11 is popped out. So, this way, you can remove also. The first item is pop up. So, you can apply this thing. Similarly, you can clone it. Once you clone, it will give a one more linked list object. And you can convert it into array by using 2array method. Okay, like this, so many methods are there. Remove first, remove last, add first, add last. Generally, these are the various methods. And you can check whether item is available in the linked list or not. So, if it is available, it returns true. For example, I want to check in my linked list value 77 is there or not. If it is there, it returns true. Else, false. Let us check contains. If numlist dot contains, I want to check 77. 77 available or not. If it is available, found. Else, not found. Actually, in my linked list, 77 is not there. So, I'll say not found. System dot out dot println found. 77 found. If it contains. Else, if it is not found, returns false. If it returns false, it goes to else part. Else, Here what I will do? Here I will not found. 77 not found. So this way you can apply this thing. 77 not found. Control this. Let us run the program. Compile it. Check it. Yeah. Now my answer is 77 not found. Because in my list only 18 and 33 are there. Later on 77 is not there. So this way you can solve the problem. Now other methods also available. You can use as per your need. This is about what? Linked list of maintaining only integers. Only integers. If at all you want to maintain strings, then you should write string. How to write? Let me control N. I'll simply show the template only. The remaining part you can do, you can practice. Assume here import java dot util dot star. This is my class. Now here what I'll do? Class linked string. Assume my class name is linked string because I want to maintain linked list of string items. In the earlier linked list, I have maintained only integers. Now I want to store only strings. First string, then second string, then third string, fourth string, like this. So now, how to write? Public static void main string arguments array. Here what I'll do? I'll define one linked list. In the angle bracket, I'll specify string. So whatever the item you want to store, that data type you have to mention in the angle bracket. Linked list. In the angle bracket, assume the name is string list. strlst. So here you should mention what type of data you want to store. This is the one which specifies what kind of data you are going to store in the linked list. This, how to initialize this equal to new linked list angle bracket parentheses. So now this is initialized. After initializing, you can add it. Now if you are adding a string, assume I want to add two string. String list dot add. Assume I am entering Krishna. Krishna is my first string which is added to the string list. Similarly, string list dot add Akhil. AKHIL Akhil. Similarly, string list, and remember whenever it is a string, you should write within double quote because a string constant represent within double quotes. You may ask a question, can you store a variable? Yes, you can store a variable also. Let me write string s equal to Ramya. This is my string. You can add like this also. String list dot add s. So now s is what? String variable. In the string variable, Ramya is there. Automatically that name will be displayed. Means that is stored. Now I want to display system dot out dot println string list. Control S. What is the name of the program? The name of the program is linked string. Control C, Control S dot Java. Program set linked string. Clear the screen. Java C linked string. Now in the earlier program we have stored only integers. Now I am going to store only strings. Now Java linked strings. Linked strings. Now run it. Yeah, I got Krishna, Akhil and Ramya. It follows the insertion order. So in this way you can maintain any kind of linked list. Assume I want to print one by one through iterator. print one by one, print node by node, node by node, because every node having one item. First node is Krishna, second node is Akhil, third is Ramya. Now I want to print node by node. First of all, let me get iterator, ITR. I should get from the linked list str underscore list dot. There is a method called iterator method. Iterator. This method, what it will do? It will return one sequential generated list. From this iterator, I will iterate one by one. That means repeat one by one, get one by one. So to get one by one, you can check while whether still the iterator having some item or not. If item is there, I'll get the next item. Then I will keep on repeating until I reach to the end of the list. So ITR is my iterator object dot has next. It is my method that returns true or false. If it is available, returns true. If it is not available, returns false. Let me print it. System dot out dot println ITR dot. To get the item, you can write a method called next. So now this will repeat till end of the list. So here you need not write the index I plus plus I plus plus. Now iterator will be going in a sequence one by one until you reach end of the list. That is the advantage of iterator. Now go to the program, clear the screen. Java C, string list, sorry, linked string, Java, compile it, Java, linked string, dot plus, remove, yeah. So I got one by one. So using iterator, I am getting first Krishna, then Akhil, then Ramya. So this is the way you can do. This is 3. These 3 come through iterator. And this one directly I am printing the object. I hope it is clear. So this way you can solve all types of operations on linked list. So the remaining classes of the collection will see in the next session. Okay. So you can go through this code to store all types of, or you can do any type of operation on the linked list. And remember, the Java P is the best tool to know about what methods are there. Use Java P tool and get the method name and apply it. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.